Hello, everybody, and for those watching in the live stream, we're going to be starting in maybe around 10 minutes, so just hang tight. turn the microphone so it works. Good evening, everybody. I am Johnny SDS. I am the head of engineering for Siteminder here in Manila. Thank you so much for coming to the meetup. Tonight is a special night. This is the first time in a very, very long time that we have an in-person meetup for Node.js Philippines. So I'm very, very happy that you guys are here. Just a couple of housekeeping issues. We are going to be live streaming the event on Facebook, on the Node.js Philippines website, and on my YouTube channel for those watching. Hi there, guys. And we are going to be using Slido for our Q&A. So when the speakers are here and you have questions, just go ahead and visit slido.com on your phones and go ahead and enter the code NodeJSPH, and you can submit your questions there. We're going to be reading off all the questions after each of the talks. So I actually wanted to introduce Thomas Laughlin, who is an old friend. He is the organizer for Node.js Philippines, among many other meetup groups, and he is going to introduce the speaker. So, Thomas, here you go.
Thank you so much, Johnny. We appreciate it. We appreciate Siteminder hosting us. Welcome, everybody, to Manila JavaScript number 42, right? Jesus. So we've been doing this now for 7 years. We've been doing it for a long time. This is our first in-person meetup since COVID. So welcome back. It's been a couple years. We've done some online meetups, right? Again, with the help of Johnny. He's amazing. So we have a few different talks today. We're talking about functional programming. We're talking about some kind of testing. We're talking about workers. And our speakers are ready. They're here for it. They're excited. They're ready. Brief background about us. Manila JavaScript, Node.js Philippines, and all of you guys, right? We're excited about JavaScript. We like doing JavaScript. It's a cool language. It does so many things. It's wonderful. We love it. You love it. We're all here for it. And so we love talking about it. We like bringing in speakers from around the Philippines and around the world who come in and discuss, their favorite parts of the language, things that they love to do, things they like to work with, things they think you should know about, right? So for the people online and the people in person, welcome. I hope you learned something today. Be sure to ask good questions, right? So you got the Slido thing. I've never used that. And then hope it works. And then in-person people, please, ask questions and stuff. Be engaged, right? This is a learning opportunity for you, way better than school. Without further ado, I'm going to introduce our first speaker, Junel Capawing, who is going to be talking about functional programming in JavaScript, right? Is there such thing? Oh my gosh, I think it is. Oh my God. So not just object-oriented anymore. He's going to teach us something new. Mr. Junel, please, take it away.
Yes. All right. Thank you, Mr. Thomas. All right. So my talk for today is functional programming in JavaScript. Oh, sorry. Yeah, of course. All right. Hold on. Is it full screen? All right, let's go. Okay. So my talk is functional programming in JavaScript. So we have to understand it, and I will give you some reasons on why you should at least consider using functional programming. So, to start it off, what is actually functional programming? But before that, I actually forgot this slide exists. I'm sorry. So we'll be going through what functional programming is, what the benefits are, because yes, there are actually benefits to using different paradigms in programming, especially functional, especially if you're going with JavaScript as your main language. And we will also discuss some use cases for this. And so I've been talking about how beneficial functional programming is for you. So I want to first explain what it is. So it is a programming paradigm. It influences how a developer approaches a problem, how he codes, and how he resolves a problem. So what do I mean by that? Essentially, it means it is a methodology. So it's a method of how you code your program. It is a way of resolving something. So it's a different style of thinking. So when I say functional programming, it differs in the way that, for example, you approach object-oriented programming in such a way that you think of things as objects, right? So you think of like a table. So you have different parts of a table. You have the legs, you have the wood itself. for functional programming, it's very different. You approach it more kind of mathematically, in a sense. I'll explain that later. But there are also other paradigms that exist. So for me, the big three that I found was imperative programming, object-oriented, and functional. Imperative programming is what we commonly use in bash scripts. It is a step-by-step process of how we should do something. So more of like a recipe. But then you would argue an algorithm itself is a step-by-step process, right? So what's the difference between like an algorithm and like imperative programming? Again, it comes back to the style of thinking. It's how you think, how you approach the problem. And for object-oriented, I explained earlier, you approach things, see it as an object, how it relates to one another. And functional, yeah, this is the cool part. You approach things in a more mathematical sense. So it takes in, essentially, you take in multiple inputs and you try to simplify it down to a singular solution. So for example, we have this formula right here. So this is the quadratic formula. Yes, I remember. Muntikan ako na makalimutan. But anyway, so this is the quadratic formula. Essentially, what functional programming does, you take in multiple inputs. As you can see in this, we have multiple inputs. We have the coefficients A, B, and C, but you always have one singular, or two, in this case, two outputs. They're very predictable, and you always know what to expect. There are no side effects or no side answers. You will always expect two roots from this problem. So that's how functional programming is approached. How functional programming is like, how it gives results back to the user. So if we would apply this in a programming sense, so we would have like a function there, right? We would declare a function and go through the steps the same way as we did over here. So I will not enumerate the steps because honestly, I forgot how to do this formula. I just showed it for example purposes. But the point here is that you would do the steps you would do in this formula and then apply it here in the program. But the thing here is that, in my next slide here, given any specific input, you will always be returned with expected values. And there are no side effects again. So what do side effects mean? So side effects is when you run a function and something other than your expected value is returned along with the function. So for a common example of this is like console logging inside the function. So I would call that a side effect. So it's not what you would expect when you return something, a value. You wouldn't expect like a function that computes for a number to return a console log, right? You would not expect that. So that's a side effect. In functional programming, you don't return side effects. I will discuss the benefits of not returning side effects later. So another thing is that you don't take inputs outside of the specific parameters that you set. What I mean by this is that if you have certain parameters, let's go back. Yeah, there we go. So here we have A, B, and C as our parameters. Again, you would not take any additional input outside of the function. So like if you have any global variables declared, you would absolutely not take in that value and compute it using the function. You do not want to do that because it will give you unexpected results. You don't know what the input is in the global scope. So that's what I mean by no side effects and by giving exact results. You want something that you expect will come in, and you also want something that you want outside that you expect. The reason why we won't use global variables is because you don't know what a global variable is. It's not what you expect in the scope of this problem. So that's one. And this concept is called pure functions. So pure functions, I already explained it to you. Pure functions take in specific input, do simple logic and computation with it, and returns a result. That's it. It will not return anything else. So that's what it does. So We call it pure functions because, again, I will say this again, you take in something specific, it will return something specific that you expect. That you expect. That's the key word. You always expect the same result to occur. So that's the problem, I guess, that pure functions resolve. And then we also have something called higher order functions. So higher order functions are also functions that take in a parameter of a function, or they may spit out another function as the result. I know that can be a bit hard to imagine, right? So I will first explain this and I will show an example. So it treats functions as objects to be passed around. Higher order functions does that. And it can be layered to produce like, it can produce different results. So more of like, do this, and then after that, do this, and then after that, do this. That's the most simplest way I can explain it. But layering is more of like chaining together multiple higher order functions to produce a single result. The good thing here is because they are in functional programming, you can always expect the output to be the same. Not the same, but as you would expect. It's not something different. I know it's a bit hard to grasp for now, but over time I will, hopefully, you might get it over time as well. So, an example of a higher order function is the maps function in JavaScript. So given our constant of names here, we want to manipulate them and change their values inside. Normally, in object-oriented programming, you would introduce or make a function that will use a for loop, iterate over it, and then change it. And the different thing here is that you would do so on the same variable or in the same array. Usually that's how it goes. But in functional programming, it's always a good idea to use const. I mean, it's okay to use let, but then you would be changing the values inside of the variable. And then if you try to debug it, you wouldn't know which part of the program changed the value inside of it. So it's always a good idea to use const in JavaScript. var is deprecated. So if you see examples in the internet that's using var, please don't use it. It's very unsecure. It's dangerous. No, don't use it. You can use let. Let is like another type of variable declaration where you can change, but it's not really recommended in terms of functional programming, as I stated earlier, because we want to keep our variables true to their nature. We don't want to change anything. Once the values are in, that's it, so that we can keep track of the changes. Right, so here, excuse me, so here we have map. Map is an array function that takes in another function as its argument. So here, what we want to do is, given these names, we want to input the string hello and the name into another array. So what this does, what map does, is actually simplifying the for loop into a single line. So, given the names, this is what we call an arrow function. So, names that map will pass the value of type name, and then for each name, it will return the string hello and then the name. So you can imagine this name here, hello, put in, name, hello, and then in. It will do that until the end of the array, in a new array, okay? Again, I explained why we would want to use different arrays. I know what you're thinking, like, isn't it like a kind of a waste using different variables if you just want to change something so simple as changing the value inside to hello? But well, there is a solution for that actually, but I will discuss that later. But for now, this is the style that we will approach, okay? So this is an example of a higher order function where it takes in another function and then it manipulates it according to what you want. Next we have, this is another example of a higher order function, a custom one, if you will. So I have here a function called adjective. It takes in a string called adjective, and it returns another function of type, which takes in another string. So if you call adjective into a variable called nice, and you insert the string nice into the adjective, nice will actually become a function. So you can use nice to insert another variable, and then it will output both the adjective, the first one, and your second one. So that's what it will return. So this is what it means by returning functions as a parameter. So it treats it like an object, as you can see here. So you can pass functions around and do whatever you want with it. I know when you're trying to read this for the first time, especially if you're not into functional programming, it can be quite difficult to grasp. I know when I tried understanding this part of the code, it was very hard to understand. But just imagine that you can also take in functions as like objects. You can pass them around like objects as well. So that's the main thing to understand when you want to understand higher order functions. So there's this problem, not a problem, but how we classify functional programming and its approach to its problems. So we say that functional programming is declarative. It focuses more on the bigger picture. It focuses on what to do rather than how to do it. Imperative is showing how you would resolve a problem step by step. So that's what I mean when I say step by step. But functional programming approaches the problem in such a way that you only need to say one thing and it abstracts everything away for you, giving you a simple answer. So an example I would give is this. So here in the white part is what I would call at least object-oriented or imperative. This is a common function that we would use to add the numbers inside the array. So our sum function would take in the array, and it will calculate using a for loop. Simple. So you declare total, add total by the indices of the array, it adds it together, it returns a total. Simple. But in functional programming and in JavaScript in particular, you also have other functions that can do the same thing. So in this case, we have array that reduce. Array that reduce takes in multiple inputs and then simplifies it down to one. So here, again, reduce is also another, what do you call this, higher order function. So it takes another function as its parameter. And that function, that parameter, will do the calculation for it. What reduce does is just it iterates over. Okay? So you can imagine reduce and map as like the for loop. And the operation inside it is this operation right here, the function which you passed inside, right? So prev and next are the first and the second indices of the array. Initial is the one that reduce will compute on the first one. Because let's wrap our head around this for a minute, okay? So if we use prev here on this part, next would be 1. So that means the one before it is undefined. So what are we going to declare it as? So that's the reason why we declared an initial here. So that this undefined value on this left side here will become the previous. And then what the function will do, this function right here, is it will add the two together and then continue that until the end of the array. And you would also see that you don't need to use this part, this return total, because as you can see here, the result that reduce will pass back to you is the result of the entire thing, of the entire problem. Whereas here, you would use so many lines just to console log a result of 10. But like, if you use reduce, it's just down to a single line. It's essentially down back to a single line. All of this here, compared to here, is just one thing. So that's what I mean by abstracting away the instructions. An practical example of this is like a recipe. It's like a recipe, right? So if we're trying to cook scrambled eggs, an imperative way of doing scrambled eggs is that to make scrambled eggs, we first have to get some eggs at the supermarket. Because how would you make eggs if you don't have eggs in the first place, right? So you don't assume anything in imperative programming. But in functional, you would assume some things that you think are there. And I know it's kind of hard to grasp that making assumptions in the part of the programming is like hard. But in order to cook scrambled eggs, you would assume the egg is already there compared to here. Because here, in the functional programming part, eggs is the input, right? So how can you crack an egg without an egg, right? So what I'm trying to say here is that if you're trying to code functionally, you would do it like this. You would just say the steps of what to do and let the computer figure out how to do it, okay? So whereas here, you're trying to specify everything and anything. You are micromanaging the program of how to cook an egg. Whereas here, you abstract away all those instructions and just tell how to make an egg. That's it. So that's the concept of like being a declarative type of methodology compared to imperative. So it abstracts the concepts. It makes assumptions based on inputs that you have. So it connects back to that pure functions where you take in specific input, right? That's because in order to be functional, you always have to specify the input at first. So when you go into a more declarative setting, you make things more readable. Because I can tell you, you would not read this. Absolutely not. What I can tell is that this one is much more easier to grasp and much more easier to understand compared to this, because this is like an essay. And we tend to go for the more simpler things if we want to understand, right? So that's how declarative programming works. Another part of FP's approach to his problems is immutability. So earlier, we used two variables. When we wanted to make changes to the first variable, we put those changes in another variable as well. So the concept of that is called immutability. Immutability is you avoid the mutation of data. So once data has been set or declared, it's a good practice that you should not change this in the context of that variable itself. Why? Because when you change or when you manipulate the data and something goes wrong, may sumabog sa program, something blows up, it's very easy to detect which part of the program made the breaking change because you use different variables to see where the change was made. Whereas if you use the same variable over and over again, you don't know which process broke that particular thing, right? Whereas if you use different variables for different things and manipulations, you can see in a much more easier sense where the program broke. So that's the program that immutability, no, that's the part where immutability is trying to solve things. So let's take in these names. So if you would notice, I use let here in this instance, right? I use let, and then I changed the first index to another value. So now instead of this, we now get this. We get bay. But then, let's say the program broke or something broke while in this process, or maybe it's trying to do something else. It will be very hard to debug this because you only use one single variable, but the process was different. All right? So if you're trying to debug this in a much more bigger program at scale, let's be honest, you won't figure out, it's going to take you at least 2 hours to figure out where the problem was. So that's a good example of how immutability works when you're trying to debug code. Because, let's go back here. Where was it? Right, this one. Because like here, look, if we made changes to the array again, and then we had a new array with the changed value in it, if something goes wrong, the program would point you to this new one right here. So you would know which process manipulated this specific variable. And you would know much more easily where the problem is inside that context right there. So here, it's the same thing as before. Here, we use let, and we change the value inside of the same array. But here, we used names.map to change the value inside. Same output, but we used a different array for this, right? So, if something goes wrong, if the JavaScript interpreter points here, then that means there's something that happened inside this function that you're trying to compute, or this one you're calling right here, right? So it's much more easier to debug if it's like that. But then you would question yourself, like, yeah, sure, you can debug it, whatever, but like, it still eats up memory, right? It's a waste of memory. If you're just changing one value, and then all of this stays the same, isn't that kind of like a waste because you're copying the values again? So if you could imagine a big program at scale, what would happen is that you would have multiple different values of the same thing. So yeah, that's gonna eat up memory a lot and fast. So in order to avoid that, there's something called persistent data structures in functional programming. Now, I wanted to include this topic, but I will be the first to say to you that I am not an expert in this part of functional programming because it can be quite difficult to grasp at first. But let's go through it together. So, immutability, again, earlier comes with some performance cost because you're, again, if you're trying to change one thing, you would copy the entire thing to another variable, and it's just a lot of work. But persistent data structures avoids this, and you can use these libraries, Mori.js and Immutable.js. So those are libraries that you can use if you want to implement this. But persistent data structures was introduced by Phil Bagwell in his paper called Ideal Hash Trees. So this means that persistent data structures, we would convert them into trees. So in JavaScript, no, not JavaScript, I think it was Clojure. Rick Hickey in Clojure implemented these persistent data structures. So it represents an array as a tree, where if you add a new element, it takes all the leaf nodes, and then you make a new node out of it with the changed one as the new element of it. So what you're essentially doing is you're creating a new node that references the leaf nodes of the original plus the one that you made. So what do I mean by this? So let's take this array again. So we have, in this array, we have two values, fauna and crony, and we want to add another value in it. But without copying the data again, in terms of performance, we don't want to copy them. So what we did is that we just created a new node, and that new node references these two right here and adds the new value here. So when you call this new node, it will show these three, but if you call this array, it will only show these two. That's because this new node is just referencing these two. So in a sense, they're not being copied, they're just being referenced. That's what I mean. So now that we've learned these concepts, these crazy concepts of functional programming, I'd like to introduce some benefits to it. So, pure functions allow for easier unit testing and modularity. Because pure functions they are supposed to do what they're only meant to do. You do not want to, for example, if you want to calculate a sum in a function, it will only calculate the sum. Don't make it calculate like the square root of another thing. Just make it do what it does. And because of this, of its simpler nature, you can easily debug where a problem goes wrong. Because if there is a certain process that like made a mistake or in the calculation or something like that, it will be much more easier to find out because you used pure functions. So, say for example, if you have a calculator app and then something in the addition part goes wrong, you would instantly know it's the addition part because that's what it's meant to do. The function addition is supposed to add things, not subtract things, so it's like that. And the declarative style also allows for better readability. So again, like earlier, we used in the example earlier for sum, we used a for loop, we declared some variables and stuff. But for the functional parts, or the functional side of that, we just used one function called reduce. So essentially, what we did was we compressed or abstracted away a complex thing into one single function. So you don't have to worry about what it does, just know that it will return what you expect. So that's what it means by better readability. And immutable data ensures better bug tracking, since data is not being changed down the line. Of course, like, data will always be changed and manipulated inside the program. That's just how programs work. But what I'm trying to say here is that because you are putting the manipulated data in another variable or container, you would be much more easier to debug or to know which part actually made the mistake, right? Because again, if you manipulated the data in one singular variable and multiple processes worked on that singular variable, it will be very hard to know where the mistake was made. So this is another benefit of functional programming. And the use case for this is, I would argue myself that you don't have to use functional programming in every aspect of your program. Let the data decide where you would want to use this kind of methodology. Because I believe that data-driven programming is the way to go. So it just depends on how your data is structured that you would manipulate it. So what I'm essentially doing here is I'm giving you options on how you should manipulate your data, on how you could manipulate your data. There's just not one way to manipulate your data at all. There are multiple ways, and this is one of them. It's called functional programming. So again, let's say if your data is critical and needs to be ensured, it is transformed properly, right? So by transform properly, you would need to ensure that every single time you would change something, you know that which part of the program is making the change at. So functional is good for that because of immutability and pure functions. And if you want your program to be versatile and very, very simple to read, again, functional programming does that because it abstracts away the point of the micromanagement per se of how you should implement it. It just says, okay, so this thing reduces this thing to one singular point. So that's it. You don't need to know how it reduced the problem to one singular point. You just need to know it did. And of course, as I've been saying earlier, if you want to locate bugs, it's much more easier because of immutability, pure functions, and higher order functions. Right. So if you want to learn more about functional programming, then I honestly recommend these links, especially this YouTube video here by Vakil A. She explained here what essentially I did, but in much more depth than I can ever hope to achieve, because I'm still learning this functional programming thing. And I want to share it with you as well because I think this is like better in many ways than to what we're being taught here with object-oriented programming. Yeah, and a cool thing is that I never actually knew this existed in the first place. So yeah, I hope that this enlightened you to different ways that you can code or how to approach something in code. And yeah, so that's about it for my talk. Thank you very much for listening. I'm Junel from AMAGI. Thank you.
Do we have any questions? Oh, Jerry's going.
Oh,
please ask a question.
no. Please.
Hello, good evening.
Hi.
So you said that functional programming, we tend to avoid side effects,
Yes.
but we write programs to do side effects, right? That's just how like it is. Like we want to commit to our database or want to generate files or reports, which are all side effects.
Yeah.
So what are your considerations on like where to use functional programming and where to do the side effects?
Yeah. So here in this part, I said that the use case is let the program or let the data decide where you should use functional programming. Yeah, that's a good question. I did not actually mention that side effects sometimes are unavoidable. You cannot avoid side effects completely. But what I'm trying to say is that as like a general rule, at least try to avoid side effects when you can. It's not that you can't. As much as possible in every aspect of your code, you should at least try to avoid it as much as you can. So if you can't avoid it in like say querying a database, then it just can't be helped. All you can really do at that point is to just use an error handling method or maybe error handle it yourself with a try-catch method. But what I'm trying to imply is that as much as possible, try to avoid side effects. So that's the point of it. Any more questions? Oh
We have another
no.
question. Alyssa, go.
People are gonna grill me. Oh no.
Hi.
Hi.
So you mentioned persistent data structures, right? So
Yes.
I've never actually used that. So I was wondering when you would consider using that in a project. What's the, I don't know, the use cases for it?
Honestly, myself, I would never use it.
Oh,
It's too difficult for me to implement it personally. But I put it here so that I can give people options if, like, say, they're much more advanced and understand how a tree works inside, like, a programming language. So they can apply persistent data structures in them. So I put this here merely as, like, an option if people want to use it. But that's a good question. When should you use persistent data structures? Well, honestly speaking, the way I see it when I was trying to understand this part of the presentation is that you would use it if you have a program at scale that tries to manipulate data at scale. So you don't want values of data being copied just for a single operation, right? So I think that's a good way to implement persistent data structures is when you're manipulating large amounts of data and you don't want them to copy every single time an operation is made. So yeah, that's one case I would think of. Any more questions?
Looks like we have another question on Slido.
Holy
Right.
crap,
Excuse
someone
me,
actually
excuse me.
used that.
Do you have another simple example of code in object-oriented programming versus what it would look like in functional? What's a good example, something simple that you would think of between object-oriented and functional?
Object-oriented. Another simple example of code in OOP. On the top of my head, I can't seem to think of anything at the top of my head right now. So, Thomas, do you have any like examples?
Well, sure. I mean, obviously, what you were saying about pure functions, where you were doing a couple different things, right? So you were making the pure functions that were very simple things. You were passing those into different kinds of loops, and then you were talking about the currying, right? Those are very versatile things, right? In object-oriented, you were saying that you could do very complex things that were overly verbose.
Yes.
Whereas functional helped simplify the entire code base. It made sense to me. Mr. Anonymous, come back with more questions. Okay. But I think we're good right now. I enjoyed it. Everyone else enjoyed it. June, good job. Clap, clap,
Thank you.
clap, 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 clap.
Thank you.
All right. June. All right. So thank you, June.
Thank you, Thomas.
I'll take your microphone. Thank you, sir. Mr. Joseph, come on up, sir. So I wonder if you guys noticed when he put in his bay, right? You saw bay show up a lot, right? It's an Easter egg. I don't know. I'm sure he meant to do it. Next, we have a guy named Joseph Doctor. He'll be talking about workers and threads and stuff. That's for you. So, little known fact, Joseph Doctor, his relatives were in a 1985 movie called Spies Like Us. There's a joke in it where everyone's a doctor, and they're also named Doctor. So everyone's doctor, 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 doctor. All right, here. In view, full screen. Nice. Okay, so just use the arrows. Cool. So, oh my gosh, Joseph's going to teach us about clusters and workers? No way. Tell us more, Joseph.
Hello. Welcome to NodeJS. I'm Joseph Doctor, as already introduced. Today I will be talking more on clusters and workers for Node.js specifically. First, let's discuss what JavaScript is. First, as you can see here, the start is your JavaScript code. And where does your JavaScript code normally runs on? As most of us would know, it runs on a browser base. So this is why we can just input some JavaScript and we can run it on our browser and specifically in our console. But the problem is, why would we use a browser for our server? So here's where Node.js comes in. It is a runtime environment that runs on Chrome V8 engine. So what we're doing is we're taking the engine of Chrome, which is the V8, and using that to run for our server. And there's actually two things here. There's V8 engine and there's libov. I don't know if I'm pronouncing it correctly, but basically here, V8 engine is the one that runs your JavaScript code, and your JavaScript sends the asynchronous tasks to libov, which is what other calls as C++ API. This is how JavaScript is able to do asynchronous tasks rather than being single-threaded and you're going to block your I/O. You just send the task to libov, then you wait. You just continue on with your code, and if libov or C++ API responds, you can continue on with that other task. Next. Here. As I have said, JavaScript is single-threaded. Here we have the event loop, async, and concurrency. First, the event loop. Here is the initialization and callbacks. Normally, here event loop is what do you call this? Event loop is what makes it possible for you to create asynchronous tasks in JavaScript. Here, event loop is what sends the data to the C++ API libov, then it gives it back to our main thread. And async, simple explanation here is, tell me when you're done, I need to do other things. So a very simple example here for a daily life thing rather than just programming is a microwave. Let's say you want to heat up your food. You go to the microwave and you put it there. Then you just let it heat up. You don't look at your microwave waiting for it, but instead you await. That's why there's async await. You await for it to ting, and you'll just go back. That you don't look at it and wait. You can keep doing what you want to do in your life and not waste time there. Concurrency is different than asynchronous. You can do with concurrency, you have other people to do things. Like for an example would be in let's go back to cooking, though microwaving things are not really cooking. Concurrency is more of, let's say if you're cooking, one will be cooking the rice and one would be cooking the meal. So if it's just asynchronous, only one person would be doing all of that. Like you're going to transfer cooking, then making rice, then cooking the ulam again. But in concurrency, there's two of you. One of you will be doing the rice, and one of you will be doing the ulam, and that's how concurrency works. And concurrency is multi-threaded and not really single-threaded. But how is it that JavaScript is single-threaded, but you can do concurrency? And that's how we will discuss today. First, we have our server here, Node.js, which is in Node.js, and we have two endpoints for our server. Here is, we just get, there are two get endpoints. First is the fast one, and second is a slow one. And if we try calling the get fast, you're going to get a response immediately since it's not blocking. But if we do this, we get slow, and it will actually not return anything. So because it's slow, it's still processing the data, even though it's async await, because you're already outside of the event loop. You're already in the main thread. But so if you try to get fast, you're not going to get any response. Even though you're expecting to get something fast, you're still waiting. So you're only going to get a response once get slow is finished. Once that's finished, your server will then respond for the fast one. So here's an example of how that's going to happen. First, I use Koa and Koa router. And here in the fast, we just have a count, and every time we call the endpoint fast, we'll just return the count, and we add count plus plus. And in slow, we have this long for loop, is lots of zeros there, so it's going to take a lot of loops to finish this. Then it's going to return the sum of how many of the index. Here, for the app use and app listen, that's just more on the routes to set up. Here's the example. So first we call the fast one, we get 0. Then we call it again, we immediately get 1. Then we refresh it, we get 2. So all of this is happening immediately. The moment we press enter or refresh, we immediately receive the data since there's no blocking in our server. So now, what happens if we try to refresh, we try to access localhost slow, and it's going to, what do you call this? Block your server, and if you try to enter fast, it's also going to wait for the slow to happen. And I'm not really, this tree is from the previous one. Then once your slow returns, which is this, your fast will also return. Exactly how I showed in our theoretical part earlier. So what's the solution for this? You can either use clusters or worker threads. So here, let me explain clusters. Basically, in clusters, you create multiple instances of your Node.js server. So here's the traffic. Let's say get Then you have the balancer, which is which will try to check each of your nodes, each of your clusters. So let's see, it checks if your node process 1, your cluster 1 is open. If it's not, it checks 2. Then if it's not, it checks 3. Then if we say 3 is open, then it will send the request here, and node process 3 will be the one who will process your request. Meanwhile, for worker threads, what happens is, here's the event loop. You create a worker thread, and it sends to the V8 live, then it goes back to your code. So basically, you don't really create a new server. All the request goes to one server, but you will assign a separate thread to process that have a CPU intensive task so that you can do your other stuff while waiting for the worker to be done with that whatever request that may be. So how do we apply clusters in an actual coding? Here is the example. We import clusters. We import CPUs from OS and process from process. The purpose of this is just for console logging. So first, we check how much CPU do we have. Then, if it's a primary, if the cluster is primary, we create a fork. So in my example here, I was running a computer with 3 CPUs, so I'll be able to create 3 clusters. Here is the else. So if you're a cluster, you're not the main cluster, the load balancer. So if we go back here, this is the main, this is primary, and this is the else part. So here's the else part, is basically the same as I just copy pasted from the start. So everything's the same. We here have the get fast, get slow, app.use, and the port. So here, if I run this code, we have we printed this 4 times. Why is that? Because if we look at the code, we logged CPU. This is the first time we ran it. Then we go to the if, and it's a primary since it's the first one. Then we cluster fork. Then after forking, we run this again from the start. Then it will see this, and it's going to log. So you have 3 CPUs, so we're going to fork 3 times. So the first instance, which is primary, plus the 3 clusters would result to 4 logs of the CPU number. Now here's the worker number. This is just the PID. And we can see that all of them are sharing the same port. The reason for this is that we would want to balance the load, as example here. We just have one port, and all the traffic will be balanced by the primary. Okay, here's the example. If I run fast, we have count 0, and I included in our response which worker responded it. This is the cluster, sorry for the wording. And if we try to access it again, a different cluster would respond, which is 7383. And as you can see, they don't share memory. So it didn't append, it didn't become one because it's a separate instance. So if we refresh again, we can see that the third CPU responded, not the other 2. And if we refresh again, the first CPU responded this time, and the count actually appended. Here, we can see that here we can see the slow part again. And I just restarted it so that you can see that the workers, the different numbers of the clusters. So first, let's try to use the fast endpoint again. But before we do that, we access slow. Sorry if I didn't show how we access this. We just entered and go back here. That's the speed of how I can screenshot things. If I screenshot this before, it will finish up. Here. So once slow is done, so even though slow was processing, localhost 80, the fast one was able to respond with a different cluster, which is 7621, even though 7614 was still processing the CPU intensive task. Meanwhile, worker threads, how different is it from cluster? Here, here the difference is we have the client sending something to our server, and our server would send something to our worker. Then the worker sends something to post message to our server back again. So here we have our server, and as an example for our worker thread, here the fast part is the same as the start as here. So everything here remains the same, but the one at the bottom will change because you're trying to send the CPU intensive task to the worker. So here's the slow, and you create an await function. And in this function, you're going to create a new worker, and you're going to wait until the worker is done. After the worker is done, it will send a message. You'll see that later, how it sends a message, then resolve, since it's a promise, it will return data to here. And since it's an await function, you're not really going to go here immediately. You're going to wait the slow function to finish. Here's the worker.js, the one we called from earlier. Here, we just basically copied the CPU intensive task, which is looping and adding the indices. Then once the for loop is done, we're going to call to the parent port, which is the server.js, that we're done. So we're going to post a message, and we're going to send the data, which is sum. So here's an example again. Localhost, we're going to use the fast endpoint again first for example. So we got 0, 1, 2. So it's working as expected. Here, we load localhost, the slow endpoint again. Then we try to access the fast one, and we were able to receive a response from the fast endpoint immediately. Then we're going to get a return from the slow. So the slow endpoint did not block our whole server. So what I want for you guys to think about is these are two different solutions for one problem, but which one is the better one? Which one is the better one to implement, and that's going to be something that I'd like you to think about. And if, let's say, cluster is better, then where do you use worker threads, or vice versa? And that's it for my talk. Thank you for listening.
Wonderful, wonderful. Who's got questions for Mr. Joseph Doctor? I have a question. Which one's better?
Which one's better? Okay. Actually, if you search the net on how do you use cluster, they're going to give you this example. Then if you search how do you use worker threads, they're also going to give this example. So which one is better? It's actually it would depend. If you want your server to Okay, sorry. Worker threads is better when you want long-running processes. So this one would be good for your worker threads. But clusters would be better if you have a lot of a a lot of people trying to access your server, so a lot of requests. Clusters would be better since you have different runtimes receiving your endpoint. So let's say your server is getting 1 million requests a minute, a second, and at least all of that will be shared by all your server runtime. Meanwhile, if it's just worker threads, it might not be able to do that. And summoning worker threads are actually very expensive, which is why we shouldn't use them too much.
Excellent. I love expensive things. Yes, sir. What's your name?
I'm June. So my question is, what does what creates the clusters, or what processes it, or it is a machine or from a node server? Like the clusters, the difference between the clusters and the workers.
Sorry?
The difference between the cluster and the workers.
The difference?
Yeah, because from my understanding, the cluster is what processes the cluster is our machine, right? Or I missed.
Yes.
And the worker is from we get it from the from the node API.
Yes.
So what's the
So the question is, what's the difference between these two?
yeah.
Okay. Cluster is an instance of your server. Meanwhile, worker threads are something that just helps your server. So it's basically workers are more like helpers. That's why they're called workers. Meanwhile, clusters, you actually have a dedicated CPU running as a server. So it will continue on running until you end it. Meanwhile, worker threads should end after you finish running its code. How can we share data across clusters and threads? For here, in threads, we have this thing called shared array buffer for the worker threads. This is something that I did not prepare for in my codes, but if you can search more about it, the shared array buffer. Clusters, actually, I've searched that you can share the data between clusters, but I think for the use case of clusters, it might be bad to share the data since you're creating a separate server. So why would you share the data between two servers for one request? The only reason you would share the data here is if you're accessing a database, because you only have one database. You're not really running 5 databases at the same time and share the data between those 5. But you have one database, your cluster will pull some data from your database and that's how you're going to share data that's the best way to share data with clusters. But there are some imports where you can try to do that.
Oh, you anonymous. How dare you? Who else is there? Oh, FJ's got a question. Fantastic, FJ.
Is it okay to use cluster and threads at the same time?
Yes, actually you can do that. I was not able to include it here in my presentation. I forgot to include the picture here. But here, can we show my screen again? Here is our cluster. So if we do have worker threads, each process will have their own worker threads. And it is entirely possible to use both of them. All right.
Thank you very much, Dr. Yay! Applause, applause. All right. Very good. Thank you, sir. Yeah, I'll take your microphone. Cool. Thank you, sir. Thank you. All right. Excellent, excellent. I learned so much. Wonderful, wonderful. So we had a third speaker. He dropped out last minute. So I had 25 minutes to make a talk, and I spent 20 minutes on the first slide. I made mistakes. I regret them all. So we'll be talking about testing web components. Have you heard of web components? Are you using web components? I hope so. Right? And if not, too bad. This talk is not for you. So I'm Thomas. Welcome, welcome. I'll give you a little bit of an intro to what we're talking about, or who I am. So I'm the CEO of AMAGI. I'm the lead instructor of AMAGI Academy, this thing. We do a bunch of stuff, right? So we've recently been focused mainly on fintech and health tech. So we focus on those two things. We have a wonderful team. Some of the people are in the audience today. I'll let you guess who. Oh, I'm having fun. You guys are about to learn some stuff. I know you're interested. I know you're into this, right? You came here with JavaScript, and damn it, you're gonna get some more. All right. So what are we talking about today? Let's find out. Web components. Okay, number 1. 2, this thing called OpenWC. Who knows what that is? 3, how do we implement web component tests? And then 4, some best practices, okay? Like I said, first slide up here. Every other slide descending in quality. So congratulations, you're up for a real treat. So first thing, web components. Who's heard of web components? All right. All of us. Let be shown, the record say, everyone raise their hand. So web components. It does a lot of cool stuff. So if you don't know what web components is yet, in my opinion, it's one of the newer, cooler technologies on the front end. A lot of people are React developers or Angular developers. A lot of people back in the day used to be Ember and Knockout developers and stuff too. So web components to me is the next stage, right? As you're building things with React or Angular or something, sometimes those frameworks, those libraries can get really heavy, okay? It can be a lot. One of the problems that we've had to deal with in the past is that we've had clients in the provinces here, okay? So there's a good thing and a bad thing to being in the Philippines, right? And dealing with performance problems, right? The bad part is that we have sometimes, especially in the provinces, worse internet than a country that was bombed for 20 years, okay? So that's an issue. However, the good part about it, silver lining, is that it makes you strong, right? It makes you focus on performance. You have to be smarter than those Koreans with their fast internet, okay? Look at you, smart people in the audience, right? You're working so hard, I know you are. So, sending a lot of data, sending a lot of information, sending all those big bundles and stuff and throwing it at someone's phone on their 3G connection in the middle of Cagayan, kind of rough, okay? So, web components is a much smaller adaptation. You're going to see some code that I very quickly copied and that actually does a lot of the cool stuff that you've been doing in React. So if you've been using Angular, React, Vue, something like that, all the different stuff you're used to and making your renders and your components and stuff, a lot of it's very familiar. So I'm not going to demonstrate all of these things because my talk is actually about testing, but we're going to look up a little bit about these elements things, right? So some of the stuff, ES modules, that's normal, importing stuff. But the shadow DOM, spooky. And then the templates and slots, I'm not going to go over this. For example, how would this look, okay? Imagine, if you will, an index.html, all right? Close your eyes, it's in your mind, and the talk is over. Thank you. All right, so you're still here, I'm still here, it's fine. Doc type, HTML, should we do an HTML class? Let's not. So, HTML, here I've got this weird fake HTML. Let's read it together as if it's our first time reading it. You have a normal HTML here with a body. You've got your script tag, it's calling some JavaScript file. We'll go find that in a second. And then we have this weird my element tag. It's got nothing in it. Crazy. Right? What could that possibly be? I don't recognize that. So let's go into my element.js. Okay, I'm importing some stuff. One of the, so web components is like its own standard. It's built into HTML. It's very cool, has nice features and stuff like I've been promoting. There is a framework for it, okay? So there are different frameworks for it. The most common one is something called Lit, which I think is run by Google. So here, this looks familiar. If you've been doing React for a long time, you get those class components. You can do it functional, but standard is class. And so I'm going to just set up some stuff, my CSS styles. I'm going to set up some properties, this little function here, my getter, probably related to a setter somewhere. And then later on, I've got this constructor. It's got super, because we're just fans of superheroes, and that's where that belongs. We put our fan stuff into here, right? Marvel for life. And then this dot title, hey there, and a counter with a number. Okay, those are things we're going to need. And then we have an incrementer. So this is a little handler function. This will, if you invoke this function, it's going to just add 1. Exciting, thrilling, right? What comes next? And then we have our render. Render, that looks normal. You're a React developer. You've seen this before. You have return HTML, okay, because we're not using JSX. So I'm returning some HTML that looks like this. It's got a title in R, which I must have had a typo, and then this counter, and then you've got a button, okay, and the button has this little click handler to it that does the increment function, okay? Cool, right? This is going awesome so far. All right, so let's continue. I have this other JS file that's just basically calling and abstracting that, right? So it's basically helping set up windowed custom elements. That's a part of the standard for web components. And then I'm defining a custom element, that all that code that I just wrote, I'm basically using that and wrapping that into something that I would use for my HTML. Okay? And then, so if we went back, because I'm not going to demo it because the slide's not here, if we look at all that, now when I call my JavaScript file here, that my element thing has already been predefined. It's going to render a bunch of stuff. Can't you imagine? Oh, you're learning. We're learning together. We're learning together, really. All right. So what is? So here's the thing. All right. So what's cool about web components, because you already are like masters at it now. There's actually like a lot of like people like focused on making this like a better, bigger standard for a lot of different stuff, right? So in React world or Angular world, you're used to pulling in libraries and stuff. Turns out there's actually like people making components for you, right? That do a lot of things, that handle, you know, extra stuff for developmenting or linting or testing and tooling and a bunch of other stuff. There's a lot of stuff pre-built for you. Like, so there's like code that this group, this consortium, very spooky again. Spooky to me. I don't know these people. They're making some code and stuff and tools that are useful to you, right? So, you know, because you don't, it's not just pure JavaScript. It's not just these libraries that you're importing from everywhere. There's some, right? But a lot of the code was like, you know, pre-built for you and kind of like a React-y or, you know, the other framework ecosystems that you're used to, whatever. So, like, if I were to like install one of them, like a testing library, this is what it would look like, right? Hooray, I'm installing something in my dev dependencies. Wonderful, okay? So it's my OpenWC testing library. And then in my test.js file, related to that original file, I would, spooky, still spooky, so much spooky. All right, so here I'm bringing in OpenWC testing, okay? It's got some stuff in it, HTML, it's so I can do that render stuff. Fixture allows me to like basically like place a node in my HTML, and then expect. If you've done testing before, you assert things, you expect things. We do that kind of thing. Here, there's a special little Mocha runner I'm using. And then I'm importing that my element.js, right? That abstraction thing that set up that JavaScript class. That's all coming in here too, okay? So, run tests, less colors. Look, I'm running out of colors all of a sudden. It's going down, yeah, we can't stop it, right? There's no brakes on this train. So we're running our tests asynchronously. We're describing my element, And then we set up our its, right? So if you've done like Mocha test before, you're used to doing this, right? So you describe your test suite and you say it does something, right? So it has a default title, hey there, and counter 5, right? Probably missing the NR thing, whatever that was. So we do that, right? Where we basically set the fixture, we just say, okay, our HTML has that element in it, that custom element, and then we expect the title of that element to equal, hey there, right? Cool stuff. And then also, slightly indented, the counter from that element should be equal to 5, right? Easy, so cool, okay? And then other things, like there was a button there, right? There was a little click, @click thing, right? So it increases the counter on button click. So you fixture, you're basically placing that DOM node, my element, and then you have a shadow root, spooky roots, spooky trees. All right, and then, no, it's spooky, man. It's almost October, the month of spookiness. And then there's a query selector. So we look for something that says button, and then we click it using the testing suite, and then the counter should now read 6, because 5 plus 1 is 13. Okay, so spooky numbers. There's other stuff going on. It goes off the page because craziness happened. Let's just act like it's normal. So other stuff. Isn't it cool? You're learning so much. There it goes. It can override the title by attribute, right? So you could just throw in some other stuff. This is just other stuff. Look at this one. This one's cool. Accessibility audit. You can test for lots of different things, okay? So each of these different, like, 4 parts of, web components that I said exist, you can test for different things, but because it's front end and because it's literally baked into HTML, it gets access to a lot of the built-in HTML features, right? So one of the things you can actually test for, and the OpenWC testing library helps you with, is testing for accessibility. And so here, if you read it, it says it passes the accessibility audit, and so we fix the custom element again, and then we expect the shadow DOM to be accessible. Right? Ooh, nice, right? We like it. Okay, so I know, you're freaked out. You're like, amazing. What else? Guys, I'm running out of slides. I didn't have enough time. So let's talk about testing. All right, testing, best practices. Okay, now I know you test. I know you're a good tester. I have a lot of people here who know me personally, and they better be testing every day, right? Right? We're all testing every day. Every single thing you've ever made has like 3 tests on it, right? Please say yes, please. I know you guys love tests. You're doing testing so hard, right? So write better tests, right? Let's write some tests. Let's discuss this, right? So here's where, I'm getting lazier, right? It's going down. Don't use the test prefix for test methods, okay? When you guys are doing testing, and I know you're doing testing, if you're in this room, you better be doing testing, right? It's not just for the QA team, right? So anyway, I'm going to be referencing JUnit because if you don't, I'm just making it like general, right? But if you're using tests in general, there's a way to describe things. Let's go ahead and explain like a version of this. Here's some things I copied off the internet. Test results. So a lot of people write like crappy names for their tests, okay? Test this, test that. No, obviously it's a test. We're good with the word test. You don't have to keep saying it. Saying things like, it returns something, it saves something, it renders something, it does something neato. Those kind of things are better ways to do this. You should write it like a human, because you're a human, and I hope you're a human. If you're in this room and you're not human, that's spooky. I just made that up. I don't know. This is a theme now. I can't wait to do this again next month. So, number 2, structure your tests in given when then formats, or arrange your access asserts, blah, blah, blah. Especially make sure that assert part actually takes place. I don't know what I'm saying. Tests that do not verify the outcome are harmful, okay? If you write bad tests are bad. That's easier, right? It's way easier to describe this. As they create impression that the code is tested when it's actually not. So yeah, if you write bad tests, that's bad. Don't do that. Number 2, don't overuse mocks. So some people try to mock like a whole database. They'll try to mock everything, and they'll try to actually make it so that the test will pass, right? They'll say, here's my fake data that's formatted and works exactly how it should. And you're trying to handicap your way into a passing test. Don't do that, right? So in general, you might have data It might not be, it might have several different steps through your application, through your system or whatever. You know, building the data to try to like make its way through all of these different functions, and you just have a bunch of unit tests that are firing. Yeah, there's ways to game those things. Try not to do that, right? If you have a bunch of unit tests, or if your data is making a long travel and being mutated along the way, make an integration test, okay? Right, so literally just plan ahead and build tests that go the whole way. Don't try to like use things to fake things. Use code coverage tools to ensure that you did not miss anything. So what is it? Overalls, coveralls, something like that. There's a bunch of others, libraries that will check your code coverage. So here's the key thing. Code coverage, not meant to tell you how much of your code is being tested. It's trying to tell you what things for sure are untested. Ooh, yes. We're all getting so smart. Spooky. All right, ready. Go, next one. Or you could just do test-driven development because you're good developers, right? Test-driven development, not a bad idea. If you don't know what it is, basically, you're writing your tests while you're writing your code, okay? So basically, instead of writing all your code, then writing a bunch of tests, no, you do them together, right? So you write your function halfway, you test to make sure that that part's working, then you complete it, and then you make sure you wrap up your test, right? So basically, you do them together, asynchronously, workers. Cool. Flaky tests. Okay. Sometimes you'll build a test and then it does and doesn't work. Okay. It's like a Schrodinger's box of tests. That's bad. Okay. If it does and doesn't work and you're not really sure, there are different like libraries and things that can help you to make sure that you run it and it runs properly. So basically, you can just set high reputations. You can build your own thing for this. It's really up to you. But if things are like sometimes passing and sometimes failing, and it's the same thing with like the same data, you built something broken. That shit don't work. Okay, don't do that. I'll try not to cuss. I'm sorry. Yeah, don't. If you're bad at writing tests, just practice. Like, please write good tests. Unit tests where green type of issues are real. Don't rely solely on unit testing or you'll end up in a bad place, right? Write integration tests. Don't be afraid to be creative with testing. I honestly don't mind writing tests. Tests are kind of fun, right? Whether you're testing your own code or you're testing somebody else's code, you're trying to jab that person, right? Screw you past me, right? And then you teach them a lesson, right? That they'll never forget because they're not here anymore. It's just you. All right. So honestly, writing your tests, unit tests, okay. Integration tests, better, right? Super or mega integration tests, have you ever wrote them, right? Shh, it is legend. So there are other types of tests. You should write them all, okay? Test well. Like, if you don't know how to test, talk to me afterwards. Let's talk about tests. Oh, thank you. I'm done. Hooray! Yes, you learned stuff. Oh, we made it. Oh, all that copying was so hard. Okay. Questions. Who's got questions? Jericho's got questions. The jolly Jericho.
Hi, good evening, Thomas. I have a question. So what if your function has the set of inputs that it can accept is like very big, like millions of magnitude? Is it okay to write tests that would use randomized inputs? But so whenever you run the test, there's a chance that there's a case that it might fail because it's randomized, but also you lose, like, you can, if you didn't record that input parameter, like you're like clueless. So is it okay to use randomized inputs on your tests?
Cool, thank you, Jericho. Can we use randomized inputs into our unit tests or integration tests or something like that? Actually, you should. In fact, there's a concept called fuzzing, right? Fuzzing is when you just throw a bunch of crap at things, right? So if you plan ahead, you can throw very specific crap. Things that are actually like, hostile, right? So like SQL queries and commands and stuff like that. Throw that into a function, see what happens, right? See if you can break things, right? There are lots of ways hackers, malicious people, or just your users who are being very creative with your app are throwing things in, right? Oh, that's the name field. Better put my date of birth. Right, so that does happen. Whether you can stop it or not is another issue. So yeah, building tests that do randomize some kind of data, and even throwing in things that you know for a fact are not supposed to be there, like building things to not pass negative tests, right? So like, or pass, whatever. Being able to throw things in and that it still functions as it should, whether it blocks some kind of incoming request or blocks some parameter or the validation handles it or whatever. Those things are necessary and good. In terms of quantity, yeah, building load tests, right? Things that hammer your APIs, things that hammer different parts of your system that require different amounts of resources and stuff or have dedicated resources to them. Hammer them, throw things at them, throw everything, throw the kitchen sink, throw whatever you can and try to break it, right? In the end, if you don't, your users will, right? So, do it. Anupa. Yes, the amazing Alyssa.
So is it possible to create tests for styling? And do you think that's like worthwhile testing for?
Cool. Yes. Yes. Even the OpenWC testing library, it actually does do that too. Snapshot testing. This is called snapshot testing. Okay. So basically, what it is you have a DOM node. It has properties associated with it, styles and stuff, classes, whatever. You can test to make sure that those are there, right, the way you expect them to be. So there's two different types of UI testing that we typically do. Is the snapshot testing, which you look at the DOM nodes, see if they have the properties and stuff that you expect in the order that you expect. And then there's the UI testing, where you'll use something like Selenium, where you'll just click through things and things should look or should be how and where they ought to be, right? So kind of both ways. And then a lot of people just do manual testers for that stuff too. But should you test styling? Yeah, because your styling matters, right? If something is display none, right, that's an issue, right? If something is 1 pixel wide, right, and it's in the top left corner and no one knows where it is, right, that's an issue, right? There are times where your renders can get messed up. There are times when things will just not mount correctly to the DOM. And if it's not in the DOM, your users can't see it either, right? And if your users can't see it, they can't touch it, they can't interact with it, everything's broken. You did bad with your tests, right? So write better tests. If you write good tests, that's a good idea of a test. You should do it. What else? Stump Thomas, yes. Doctor, yes.
Regarding the maps, and what I'm thinking is, what if your application requires access from a data from another server, a third-party server, and how would you test that? Do you just buck it, or do you just try to request from that endpoint that's not yours?
Do you have unlimited access to this third-party server?
That's what you're assuming, but who knows, maybe their server might go down and your test will fail because it went down.
Excellent. Excellent. Yes, call everything you can. Just literally hammer their server with requests. Flow their data. Just build streams straight from their application to yours, right? Build whole tunnels of nothing but just nonsense going straight through. I'm sure they'll appreciate it. I think it's a good idea. So in general, like, a little bit more seriously, if you're calling a third-party API, obviously there's rate limiting and issues around how many calls or requests you can make and whatever. Those would be like separate tests initially, right, where you're testing just to make sure you're getting a valid response from them. Make sure that's there. Honestly, probably don't need to call that too many times. Once is usually enough for that. And then in terms of ingesting the data, making sure the data is coming back correctly, set up validation, do some kind of unit tests or an integration test that would just check the validation of the object coming back. Maybe do that initially. I wouldn't do a ton of them. If you have to do a lot of them because there's a lot of other tests that require that information, maybe preserve the data in memory temporarily and then pass that to the other tests during that test script. Or if you're API keys are already pretty spent, maybe just mock the data for some things, right? But in general, you want to make sure if you're relying on something third party, that's rough, right? Relying on other people, they suck, right? So, you know, do your best. What else, guys? Yes, sir. Mr. June.
Yeah. I was just wondering. It's just a thought that I had while Mr. Joseph asked this question. So
I love
his
thoughts.
was about APIs, about calling actual APIs, right? So I was wondering, would it be a good idea to make tests using real actual data? So like say querying a database and using the actual data from a database to see if your tests work. Would that be a good idea, or would it still be a generally good idea to use mock data as well?
So very dangerous, right? So technically you could, but you probably shouldn't. There's lots of reasons you shouldn't, right? Regulatory reasons, especially speaking like HIPAA, things like that. You're not really supposed to play with that data in that way. So in general, what I would recommend doing is creating a seeder, creating something that literally mocks and uses your own APIs to construct the actual data. Pass it to some kind of test database so that you know it's been validated and formed correctly, and there you're testing all your input stuff, and then query it back out, make sure it's in the form that it's supposed to come out as, and that way you're doing a very long integration test, right, where it's all the stuff that's supposed to put it in, and then all the stuff that's supposed to get it out. You're doing a very long integration test that tests for a lot of things, and that way you don't have to really deal with the private data. Just make sure when you're passing things in that you're populating random fields. Some fields are being left out. Some fields are, not in the correct form. Some of them are all full and perfect. Some of them are not, right? Try to get all that stuff and make sure that your system is recognizing it correctly. Good question. What else, guys? All right. Easy enough. Oh, we have another question. What? Anonymous, you're back for more. Does OpenWC already have tests for accessibility? Yeah, it does. When I was demoing that thing, this is actually already built in. I didn't make this. This is a part of that testing library. So check the shadow DOM and looking at an element and checking if it's accessible. Like that is just a pre-made part of the testing library, right? And so they're already doing that. Like a lot of the HTML, like core W3 people, right? They're like super into accessibility, and as should you be, right? If you're dealing with people, you don't know if they have disabilities. Especially if you're dealing with like older audiences or something like that, you can guess that they will. If you're dealing with males, right? They're more likely to be visually disabled, right? So, we all have these issues. So does it have the things already built in? Yes, you should check the documentation. The testing library that I showed you, the OpenWC testing, has stuff in it. You should read the documentation. There's a lot in it. I do not have it on me. And then there's special test runners and stuff for web components, but honestly, most test runners kind of work for this stuff. Okay? Good job, Anonymous. Thank you. All right, so that's it. Hooray! You guys made it. You learned things. Hooray! Applause. All right. So, okay. So thank you guys. Thank you, internet people, right? Wherever you are. Thank you, in-person people, for being here and enjoying my spooky tales. I hope you guys are learning stuff. I hope you guys are practicing stuff. One day in the future, invite us. We'll come speak and do this thing at your company. You want to be a speaker in the future? Great. Come on over. Speak words. And share your joys, your loves, your deep affection for JavaScript. So thank you all from Node.js Philippines and Manila JavaScript. We're happy you're here. We want to see you next time. Let us know some stuff. Applaud and hug the speakers. Not me. I don't know. But those guys, yeah. And make them feel good. And then that's it. So I appreciate it. Johnny, would you like to outro and give us some more words?
Absolutely. Thank you, Thomas. Thank you, Junel. And what's the name of the other guy? Joseph. Thank you very much. I forgot everybody's names. Yes, thank you. Thank you very much for coming. Before you guys leave, though, I actually want to turn it over to the folks from ProSource because they actually want to address you. They were kind enough to obviously, allow us to have the meetup here. So they want to have a few words for you guys. So we're gonna have, hold on a second. Got it. No. Jamie? Oh, so Jamie's going to start? Okay, so Jamie's going to start, and she's going to address you guys too. And Abe, of course, Abe is coming come as well. So come on, guys. They're actually going to set up right here real quick. While they set up their laptop. Are you bringing your laptop? Yeah, you have a presentation, right? Anyway, while they set up their laptop, I'll go ahead and talk to you guys. I actually really enjoyed the talks. I am a fanatic of unit testing, wherever Thomas is. I don't know, where did he disappear to? Oh, he's over there. I'm a fanatic of unit testing. I'm one of those individuals that is constantly, I actually give a lot of talks about unit testing as well. As a matter of fact, I give a talk about unit testing in Manila JavaScript once upon a time. I did, yeah, a while ago. It is something that you guys should definitely look into. If you're not doing it, you should definitely be doing it. Yeah, the topics today were great. Are we about ready, guys? Not yet? We're getting there, Okay, we need 1 more minute. And thank you to the people that were, on the call, online and send us a few questions. I'm trying to figure out who Anonymous was. I think I have a feeling who Anonymous was, but I'm not exactly sure. Hopefully Anonymous will, be in person next time, so they can join us, whoever Anonymous is. Are we still having technical issues? Give me a second. Okay, hold on a second. So let me, you guys start talking for a second, introduce yourselves while I actually put the presentation here on there. Don't worry about it. I don't need this. Here you go.
Okay, got it. Hi, everyone. Happy Friday. Thank you for coming here, especially on a Friday night. It's traffic outside, and we'll just talk about a few remarks on what ProSource is.
So basically, don't worry, guys. We will not be posting any possessions here. Okay, so you will not be bombarded about it, but we will just share what ProSource is, how we are doing from the inside. I think there's some issues in the mic. All good now. Okay, so don't worry about it. We'll just make this smooth and easier and light to understand because actually on the back we didn't understand anything about it, but we really appreciate about the discussion. Johnny, thank you for that as well. We are really out. Yeah, it's very technical to understand. So we'll make this discussion lighter. And as a start, let's first discuss. So this is our slide. Sorry for that. It's a lot of things to. Oh, sorry. Sorry about it. So it's a lot of things to see right now, a lot of creatives. So Johnny, can you, next slide please. So before we introduce ProSource let me first discuss, or let me ask you this question. So there's no right, there's no wrong question, so you don't need to be pressure about it if it's wrong or right. But really you need to understand also from a non-technical perspective, how do a Node.js developer make a difference in our society?
How would you explain it to someone without technical experience, without someone who doesn't know coding? Like, how would you explain Node.js? Like, how do you guys make a difference? How do you create value?
Anyone from the crowd? Actually, we have prizes here. We have a 1 million Kit Kat chocolate that we can give. So, is there anyone who can give us a glimpse on how a Node.js developer make a difference in our society?
Yes.
Okay.
I need me some Kit Kat. So Node.js, it's a server. So what this does is it allows information to go to and from one computer to another, right, essentially. So a computer has some logic in it, and then the server, which is Node.js is one of the ways of building it, can pass information from your phone or from your desktop or your laptop to a database or some other person. Okay? And so Node.js is a nice way of doing it because it's a little bit faster, a little bit easier to write, not the most complex thing in the world, and a lot of people actually enjoy writing in it, right? Is that good? Am I close?
What do you think, Jamie? It's a lot of to comprehend, but I think it's something useful in the society as well. It's a good answer on that one.
Thanks.
So let's give him a round of applause and the Kit Kat. So another one, we need another volunteer also to answer the questions regarding how you make a difference in societies right now as a Node.js developer. Yes, sir.
We can also create value on using Node.js by contributing to what we call open source software. So you write code that is public and accessible, can be reused by anyone, even like someone from the other side of the globe. They can use your code free, and then maybe that code would be like helpful in their career or the project or business that they are doing. So yeah, open source is one way to make value using Node.js.
Thanks. What's your name again, sir? Sorry.
I'm Jericho.
Let's give him a round of applause, Sir Jericho. So this is your Kit Kat. So one last participant.
I'm going to speak from a purely layman's perspective because I'm not a programmer, but I'm a tech lawyer. So the only thing that I can say about how value is created by Node.js is the fact that it promotes innovation. There was a time when we didn't have a way of transferring information, as what Thomas was saying, from one computer to your desktop or anything like that. And now it's possible because of something like Node.js. And it's not limited to Node.js. I know for people who don't program, we don't really understand the nuances of all these things. But from my perspective, it just goes to show that things are improving, that the way of passing information from one place to another is becoming faster, it's becoming better. And from a layman's perspective, I guess that's the way it adds value to us as individuals who are not necessarily into developing or into programming.
Thank you for that, ma'am. What's your name again, ma'am? Sorry. KD. Thank you for that answer. So, do you want to add something on that, Jamie? Or are we all good now?
We're good.
Okay. So, thank you for your participation on that one. At least we have a glimpse on how Node.js make a difference on our society. So, we really appreciate your efforts and contributions to our tech world. Okay? So let us first give you a glimpse on what is ProSource. So actually, ProSource, it's not actually your typical companies. So we're not actually selling the job here, but we're trying to give a glimpse of ProSource. So ProSource aims to build a community, to build a sense of belongingness, not just on the tech industry, but different spaces as well. So with that said, we do have a lot of programs and activities that aims also to build a difference, like what you said, like what our question is. We also aim to build a difference to different problems in the world, to give solutions. And that's one thing that ProSource aim is to also build that sense of community within the tech space. So that's how ProSource work is. And not just that, ProSource also promotes a family-oriented type of organization. ProSource promote work-life balance. Actually, my friend here, Jamie, she's working a lot. So as you can see on her body, so she have a lot of work-life balance to do right now. But Jamie, maybe you can share to us, to the participants, how ProSource promote that work-life balance.
Okay, perfect. Yeah. Okay, so at ProSource, they not only care about your outputs, they care about your well-being. The wellness programs that we have. This is our vertical campus. It's a 20-story tech campus, the first WELL Platinum project here in the Philippines. But the buildings by Grammys, diba? Pero here at ProSource, that's why I believe I can say that there's no really like perfect work-life balance. But then right now I'm able to work full-time and at the side study UX design in UC Berkeley on the side. So, oh, also with Abe, he finished his master's while working full-time at ProSource. So, how do you say it?
Okay, so like what Jamie said, we actually promote work-life balance. We do have different activities that we are doing right now. Johnny is very familiar with the activities. So if you want to make a difference, you can ask directly Johnny about how process work, what activities we are doing. So next slide, please, Johnny.
So here at ProSource, we're also committed to building a diverse and inclusive workplace. We believe in leveraging off individual talents to help to enable and support you to be the best versions of you. This is Nicolai Cuevo, our employee assistance manager. So if you have, she's in charge of our employees' mental health program. If you're having stress management issues, work-life imbalances, if you feel like you're alone, there's someone to listen. And next, please. So this is just the tip of the iceberg. I'm also the events and media coordinator for ProSource. We handle events, so this is like the Monday Mingle where developers can hang out with each other. We had, what do you call that? The Halloween. Yeah, we had a spooky fire office space where each team would need to like decorate their office spaces like the spookiest, the gnarliest. We had yoga on the 20th floor upstairs. We have trainings. We also were part of the Color Run Manila. So that's just the tip of the iceberg. If you guys want to know more about ProSource, you can talk to me at the back. I'll be happy and gladly to talk about the events that we'll be having and how we can support you if you work with ProSource.
So thanks for that, Jamie. And to add on that one, she actually forgot the first picture. I would like also to give emphasis on the trainings. So we also promote trainings, growth and development of each individuals. And with that said, let us end this presentation. I hope you understand how ProSource is, what does ProSource works. So we end this presentation with this quote. So community is much more than belonging to something. It's about doing something together that makes belonging matter. So like what I said, ProSource is a company that aims to build community in different spaces. And ProSource is something that promotes a sense of belongingness for a better cause and for a better solution and to create a positive difference to all of us. So if you want to know more about this difference, you can follow our Facebook page, ProSource BPO, or our LinkedIn page, ProSource BPO as well. Or you can have Jamie a conversation about it to know more about ProSource.
I'm open. You guys can just talk to me at the back.
So thank you for
so
that.
much for
Yeah. Thank you for listening. I appreciate it.
Thank you, Johnny.
Well, I think that's it. Thank you very much, everybody, for attending. For those that are here, we have some pizza and refreshments. For those who are online, sorry we can't send you any pizza, but hopefully we'll have more in-person events here. Thomas, hopefully you'll grace us with your press again sometime in the future, and Katie, of course, as always, and the rest of you. We'll keep you posted on the Facebook group and everything else when our next events are going to be. And again, hopefully we'll see you guys again. Thanks a lot, everybody. Have a good night.